How did Boeing's 737 engines go from this to this, and in the process become so large that they even have to flatten out the bottom to make room for it? Well, to get into that, we're going to have to go into a little bit of aircraft engineering. Let's start at the beginning.
Here it is. In the precise language of the engineer, it's called a jet propulsion gas turbine. To you, it's the jet engine, one of the marvels of this century of marvels.
And to explain this marvel, we're going to have to go into just a little bit of theory. But stick with me through this and you'll have some really fun facts to share with the person beside you on your next flight. All jet engines produce force using Newton's third law. For every action, there is an equal and opposite reaction. Air has mass, and if you push enough mass of air backwards like this, it's going to generate an equal and opposite reaction force in the engine, pushing it forward. The very first jet engines to be developed were called turbojets. They worked by using a compressor, which is essentially a fan, to push and compress air backwards into this smaller chamber called a combustion chamber, where fuel would be added to the air and lit on fire, generating heat and more pressure. This pressurized air had to go somewhere, so it was ejected out the back of the engine. This produced thrust. In order to power the compressor fan at the front of the engine, a turbine was added to the rear and connected to the compressor using a shaft. The turbine is another fan. It's powered by the high-speed, pressurized air as it exits the engine. In the 1960s, a different type of jet engine came into common use. This jet engine is called the turbofan. Its inner core is essentially the same as a turbojet, but the idea was to add a secondary path for air to flow through, with another compressor and another turbine. This allowed some of the air to bypass the internal compressor and turbine, and instead flow around the outside, being pushed by this larger compressor fan. It was found that it's more efficient to push a large mass of air slower than a small mass of air fast. The amount of air that bypasses the internal compressor and turbine over the amount of air that is pushed through the internal compressor and turbine is known as the bypass ratio. It was found that engine efficiency and therefore fuel economy was improved as this number grew higher. Basically, this means the larger this compressor and turbine are, the more efficient the engine is. And the whole engine had to get larger to accomplish this. And here's where Boeing ran into their problem. The original Boeing 737-100 was first introduced in 1968, right at the very beginning of this turbofan revolution. Boeing sized the landing gear height of this original 737 to fit with its engines, the JT8D low bypass ratio turbofan engine. Boeing even targeted having a shorter landing gear and therefore a lower fuselage height to allow baggage handlers to more easily put baggage into the aircraft. But over the years, to improve the design, generate more sales, and keep up with competition, Boeing has had to introduce more and more efficient engines, which means larger and larger turbofan engines with higher bypass ratios. Unfortunately, it's very difficult to increase the landing gear length on an aircraft after it's already been designed. These landing gear fold up and have to fit somewhere into the fuselage. In order to increase the length of these landing gear, the whole configuration of how they fold in would have to be changed, or the fuselage would have to be enlarged. All of this would require expensive and time-consuming design work, testing work, and certification in order to be introduced. The engineers at Boeing were able to add a few inches of height to the front landing gear. They also moved the engines forward on the aircraft and up slightly. They also had to flatten out the bottom of the engine nacelles to get them to fit. The nacelle is the housing that goes around the engine. It protects the engine and contains it in the event of a failure. Most aircraft, like this A320, have round nacelle openings. But by changing the outer shape of this nacelle, Boeing has been able to keep their 737 design alive, without having to go through the expensive steps of creating a brand new aircraft from scratch. Boeing's main competitor to the 737 is the Airbus A320. The A320 has benefited from being released in 1988, about 2 decades later than the 737. Airbus was able to better plan for the future, seeing the trend of higher bypass ratio turbofan engines and giving the A320 greater ground clearance to accommodate these engines. In order to fix this problem in the future, and to modernize their aircraft in general, Boeing will have to look towards a brand new design of aircraft in the future, as they've reached the limit of what can be done using an airframe from the 60s. It will be interesting to see where they go with this design. Thanks for watching. If you liked this video, please like and subscribe. See you next time.